Yeah, I'm just trying. What is the link again? Where is that? Sorry, I'm being fine.
At the bottom of it.
Can you check if the link's working? Okay, cool. So I'll do this up here for a bit if people want to sign in. Few people than normal.
Yeah, I'll just get started.
Okay. So welcome to today's meeting for our Data Science Club. Today's focus is going to be in web scraping, just a heads up. We still need people to apply for the e-board.
I think I suckered one more person.
Okay, so we have what, 2 people?
Yeah.
We have 2 people.
Okay.
We need more. So if you, huh?
No, one of them, incoming master student visit here. I got him to sign up. Yes. More.
Yes. So we are essentially on track with our schedule. Some of this is subject to change, but it'll just be moving it up and down. We'll still be covering all these topics. So yeah, today's special topic is about web scraping. So now what is web scraping? Essentially, web scraping is the process of extracting content and useful data from websites for you to build your own database or data lake setup, essentially, for you to run your analytics on. And now, why do we need web scraping as a tool for data scientists is due to the fact that we don't always have data that we would like. Often we need to go around and collect and collate the data before we can run our analysis or generate models from the data to test our hypothesis. And web scraping allows us to build that database by just collecting information available on the World Wide Web. So now, just covering generally common methods of web scraping, the most brain dead and inefficient method of web scraping is manually grabbing your data. If you are unfamiliar with web scraping software, don't have access to actual data, you can just Control-C, Control-V and build up your information in a CSV. It is slow, but if you have access to nothing else, it is effective. You have direct access to what information you're grabbing. You can ensure you don't miss information. And you can, actually, plus point of this is you can actually easily grab information from different websites and put it together. But it is not the most effective or efficient. It is quite painful. One of the more easier methods of web scraping is using automated API requests. Now, not all websites allow direct access to the backend of their databases. Oh, I should not have had a waiting room. There we go. So yeah, so not all websites have access or provide access to their API backend. But for those websites which do allow access to the API backend, it is a simplification of gathering their data and building up your own data set for use. Just keep in mind that most websites that do allow access to the backend API often rate limit how often you can query the backend. So just keep that in mind when you're setting up scripts to pull data from using an API backend. The reason they do this is sometimes, or it used to be quite common that without rate limits, someone else would just set up a script to pull all the data they have and set it up portraying themselves as having the data. And it just came down to whose data it was essentially. And that's why rate limits exist, to prevent bots from grabbing all the data.
Just get past it.
Yes, there are ways to get past rate limits. Essentially, like what people do is you can rate limits are often set based on IP addresses. So you can get around that by setting up separate VPNs to access the same API endpoint from essentially different IPs. And it does get around rate limits, but it's legally in a gray area because you're not breaking any laws doing it, except for like the API access, which the company set up, but it's not a law. It's just a user agreement. So it depends on how they plan to enforce it, but it's legally a gray area. And then the most common method that people use in this day and age are using web drivers. So the way web drivers work is you script user actions or actions on a website to simulate how a user will be working through the website. And as you do this, the web driver, since it has direct access to the underlying HTML to show you the data, you use that specific access to pull out your needed information using HTML tags or HTML IDs, and you can correlate that information into your needed database. So specifically going more in depth into the example here is, I just pulled this HTML snippet from Stack Overflow last night. So this is assuming you want to set up a database that lists all the questions posted on Stack Overflow to do a sentiment analysis into how the questions exist, and want to identify if the sentiment of a question leads to better answers or more answers, for example. So in this case, as you can see that the way the HTML is set up, you want to identify elements from the HTML, which would allow you to specifically get your question, the text of the question. In this case, as you can see, a common identifier that you could use would be s-post-summary-content-title. So it's a class of an H3 element tag. So using a WebDriver like Selenium, you could have it collect all those, you could have it collect all elements of that on the page. And within those elements, you could go down one level to get the A tag, essentially, which has the text drop-down menu, frame, drops, and lags, Jetpack, Compose, which was the question, essentially. So once you use Selenium or other WebDriver or other web scraping software using your choice of WebDriver and code it to parse the HTML to get down, you build up your database manually. So in this case, you would end up with a list of your questions, which you would then need to convert and parse into a more usable format for yourself.
I don't know. These tags, they have like meanings, like it's obviously subdivided classes. It's like,
okay,
div, what's H3, what's A.
Yes, I can go over that as well. So the way HTML tags work is the most basic HTML tag is a div. Div is just division. It essentially ends up being a box into which you put information or put more things into. And the way HTML works is, or the way websites work is you have HTML and then you have CSS, which work together to present the information, text, fancy colors on your screen. So using specific classes that are provided, like class here, dflex. Dflex is not a general class. It is a class that has been defined in the CSS of Stack Overflow in this case, which defines how the div is supposed to act. And each div acts as a box or a container, and depending on the class, it can end up being like a small section in your screen or covering the whole screen lengthwise or what, like horizontally or vertically, depending on how it's been defined. And then you get here, you have H3. H3 is again a separate tag, which is normally defined to as a header. You have H1, H2, H3, and it expands. And it essentially is the size of your header. The A tag is used as, normally you can use it as a link tag, or it's a tag which commonly is used for hyperlinks. And you have P tags as well, which is a paragraph tag, which is used for a bunch of text. You have image tags as well, and you can define more tags based on your CSS.
Like if you're scraping, you have web scraper pick up like the desired tag. Like let's say you want all links off a website, like say, hey, pick up all A tags.
No, if you want all links from a website, you would want to identify all tags that have the property of href, because href is down here. Href is a hyperlink reference, and that provides anything which links to another web page exists has an href tag. Now, the reason why you would want to look at the href tag is divs can have href tags as well. So clicking anywhere in the div box could act as a hyperlink. Normally, I would say that shouldn't exist because that is really poor coding, but most websites don't work off ideal code. You can expect to see funky code on the web as you're web scraping, and you need to code around it. And sometimes it is extremely painful. Sometimes you have websites that generate or tweak div boxes as you're scrolling through them because they want it to be fancy and keep like pinned elements. I have worked with those in testing and web scraping, and it is extremely painful. So to deal with those, web drivers help out a bit in where you can try and identify similar, you can use regex essentially to identify the type of data you can expect to see. And that helps, but it is not always like there's no set solution. So you just need to hope that the website you're dealing with for your information is set up neatly enough to where you can pull your data. And if it isn't, I would say just try anything you can to get your data out, because if you need your data, that's all you have to work with. And that is also why sometimes people still just use Control-C, Control-V, because you can just copy all your data from the website, paste it somewhere else, and then just cut out parts that work for you. And another note, I have seen people do this. I don't recommend it, but you can take a screen cap of where your data is and then parse that into image to text. It works. I don't like it, but it works. I mean, you have websites that do that for you now, so you don't even need to do it on your laptop. You can just say, hey, pull out text from this image. Like you can do it on your phone now with Google Lens, and Apple has an app for that too, I think. So essentially, if you want to get data to work with, anything you can think of works, and we've just provided a few examples.
HTML is so poorly written, it's better just to record like in images their code and then just get information.
Yes, I have seen that, and it's not always ideal, but it exists. And yeah, so you do what works. Just these are some references, mainly me grabbing images or using data. And now we're supposed to have a demo, but I don't have one because the guy doing the demo isn't here. So you have, if you have, okay. Should I stop sharing and you pull up, or if you join the Zoom and I can make you?
Just give me a minute.
So if you join the meeting, I can make you host. Okay. You can come up here and for sure.
Screen. Let me hide video thing. Show the video thing. I'm gonna hide. Okay, I'll set up my problem first because this is I'll set up the premise for it. This was a little project I did for one of my data science classes. So we want to look at the voting behavior of both parties in Congress to see if there was good clustering, if we could see if both parties are super partisan or if there was some people who voted with other parties and kind of what that looks like. So yeah, so the problem description is, in current American politics, it's very divided. So we want to see if this political divide shows on the data. So can members of Congress be clustered into two parties based off of their voting records? And do members of the same party tend to vote with each other? Are some people in a party willing to vote with the other party? And are there some members that are harder to classify? So the way we did this is we had to web scrape from a given website. There's actually an entire website for all bills that Congress voted on. And let's see, there should be a link to it. Yeah, so it is GovTrack. So basically it's voting records. And so we pick Congress and it gives votes each bill that was passed. So it's motion to, invoke something, whatever. And you can go through, okay, this year's Congress, here's all the bills they voted on, and it will show a nice table of every representative in Congress and if they voted yay or nay. So because this is a website, you can go in and as we talked about, there's HTML elements. So even inside of the HTML itself, you can see useful data. So this person is a Alabama Republican. Here's their name and here's how they voted. So we can see even in here, it says, okay, this person's from Alabama. They voted nay and they're Republican. So we can go into the website and scrape all that data for our own uses. So let me see, I should have this web scraper set up still. So let me pull up my web crawler, as I called it. It's been about a year since I've seen this code, so this is gonna be fun. Yeah, so here I'm using the package Selenium, which is one of the common web scraping packages. Usually in Python, you either see Beautiful Soup or you see Selenium. I don't know enough about each to tell the difference between the two. I just know that they're used. It's probably just like it's doing the same thing, but in different ways.
Beautiful Soup is an HTML process and then you uses a web driver to actually simulate user actions.
Yeah, so here you can see I can't run this. I did make a note that this will take a long time. But so here you see I download a Google Chrome web driver, like I literally install it, and then here I give it like a starting like seed URL. So I can go to this link. I shouldn't have it in quotes. So this is some act here. So yeah, so this links directly to one of the acts. But here, as you see, I have bill and range of like, I think at that point, Congress had voted on 313 bills, and the first 3 votes weren't actually bills. They're like voting in like Speaker of the House and like doing administrative stuff. So I skipped the first 3 and then went up to how many votes happened that year. And so you see there's this link here, plus, and then it's the number for the bill. So luckily all these URLs, they end in like this, like same format. So like this so this seed URL plus like H388, right? If I just change the number to like H50 or something, it'll go to the 50th bill. So this was really kind of intuitive because each bill that they voted on just gets linked to, H+1. So like I could start all the way from the 4th bill that they voted on and then look at it, and it could break down statistics, but also, let's see, where is the Democratic yay, nay? And then it gives me the voting details, right? So I just like tick up and look at each bill and looking at the voting statistics. And then I think we've all done this as a kid in middle school. You feel like a hacker because you click the inspect, on a on a website, and you get all the HTML. And if you were clever, you'd go into like Chegg or something, and every time they blurred out an image, you'd figure out how to inspect it and like take the blur window out and just get the answer. And you were like a super master hacker, right? So we're basically doing that again. We're just trying to get different information. And I'm pretty sure even if you guess right, you can kind of get into the relative body of HTML you need. Like here, like this nay is a text like element. So if I want to get all the votes, I'm like inspecting, this nay object, and then you see it here, and I can go through and iterate and like grab every nay, grab every name, grab every party affiliation, and so on. So yeah, a real example of web scraping. It'll take a while. So like here, you can see I'm like basically pathing to all the HTML like elements that I want. So like here, I'm pathing to the party vote. So there's something called, what was it, like XPath or something like that?
This is question.
Yeah.
It's finding the path to the element you want to get information from.
Yeah, so Selenium, it can take a website and then take XPath, so you can it's kind of like a directory path, right? Because that's how the structure. So you can XPath all the way down to the exact element you want for every element.
It does get confusing though, because again, depending on how websites are encoded, it is possible for multiple elements to have the same XPath, because since it's not a compiled directory, you can have cases where different things like 5 divs. And if you want to just grab one of those divs, it's impossible. So when you hit situations like that, it often returns a list of each element, which have that.
Yeah, so but there's some functions where like this is get element by XPath. So this is kind of like getting the path, but then there's also like you can, once you have it, you can get attribute. So I think that the path goes to kind of like we talked about div, it gets to the box you want. And then from that box, you can like pull elements out of it. Like here, I want the voter group 0, voter group 1, voter group 2. So let's see if I can find these voter groups in here. Yeah, class group, right? So voter group 1, we see Alabama, voter group 2, Republican, and voter group 3, I think is their actual vote. So here I went in, path to the element I wanted, and then got each element out of that box, right? And I'm sure you want to know, the results after all these studying or, grabbing all of this. So obviously we need to clean. When you web scrape, you're not guaranteed to get clean data. You're probably not because of how it breaks it up. One of the worst things we had was when it stated people's like state, if it was a 2-state name, it was 2 separate elements. So if like you're from New York, it would like give you the list New York, not New York as a single name, which totally like, destroyed our data because now our indexing was all off, and it took us a while to figure out like, why are there more states than people? But so we had to go in and like append every two word state into one. We also had a lot of like ragged arrays because when Congress votes, not everyone always votes. So you can have like less than how many people are in Congress, like 438. And also, yeah, just the data was in string format, yay or nay, so it's converted to binary. So yeah, clean data, and then we ended up transposing. So we made it like each bill, and then did they vote yes on it? Did they vote no for every single? These were the current congressmen, but this was before the last election, so this is gonna be a little bit different. Then we do some data analysis. Let's see, we did some visualization of like which we like handpicked the most kind of like politically divisive bills and saw like the voting trends, like Republican nay, Democratic yes. So this is like LGBT, Business Equality Credit Enforcement and Investment Act, and then the parties voted based off of their ideology. And then yeah, Women's Health Protection Act, and it kind of gets depressing when you read the bill name and see people voting against it, but we're not getting political in this club. So now we have to create some sort of model based off of our data, because we have all of these like vectors that say, okay, on bill 1, what did they vote, to bill 313, what did they build? So what we want to do is cluster them. So what we did was we first got the distance of all of the members to each other using Jacquard distance, which the Jacquard distance is the difference between sets. It is their intersection divided by their union. So the intersection is like how many elements in the set they have in common divided by the total number of elements. So like if they both voted on like 50% of the same bills or something like that, we could figure out the distance to each other. They also use this to find people plagiarizing, because your set of words would be very similar to a set of words that you could find online. So that's a fun trivia for you. Yeah, so yeah, one of the use cases is plagiarism. They also use it in like e-commerce and natural language processing as well. So yeah, so what we did was we made distance matrices. So that's like the distance between that congressperson and every other congressperson. So you see this diagonal is 0 because that's the distance to that congressperson in themselves. So it's 0 because they, by definition, a person always votes with themselves. And then like this person, they didn't vote like very much with person 1, and then this person voted a lot with person 1. So you could probably tell that these two people are in the same party, but we'll see. Backwards. Oh yeah, it's distance. Sorry. This person is far away from the first person. So these people voted similarly. These people are far away, so they voted apart. Yeah, I was thinking of Jacquard's similarity, which the distance, the distance is just 1 minus the similarity, but yeah. Yeah, so here is the results of our study. So these we color coded on party lines. So it looks like Republicans and Democrats cluster very easily based off of their voting records. I guess the more interesting thing to see is there's way more like spread in the votes of Republicans. Like Republicans are way more likely to not vote with each other, where Democrats are like super clustered. Like they're clustered. They're definitely not voting with Republicans, but they're also all voting with each other. Well, there's this like spread in like the Republican vote, but they're still very super distinct groups. It was very easy to cluster them. But just to put the nail in the coffin, we also did some hierarchical clustering, which hierarchical clustering is like finding the distance between like, you know, related things. So like here's like hierarchical clustering of like bears. So like brown bears and polar bears are pretty similar. So their branches merge first in the hierarchy. And as you go up the hierarchy, you get to see things that are like more different in a broader group. So yeah, the results is even with hierarchical clustering, Democrats and Republicans converge to their own groups very well, which means that you didn't have to branch too much before they got into a unified branch and distinctly made two branches in this hierarchy. Yeah.
You did the scatter. Like how did you get like X, Y?
Yeah, so that's from this distance matrix. So with a distance matrix, because you know the distance between one person and everyone else, you can use, I think we use network X, which is a package that does like network analysis and graph theory in Python. And if you hand it a distance matrix, it will make a graph for you where all the distances follow the distance matrix. So it's plotting everyone relative to each other. It's not an absolute coordinate system. You're saying this person must have all of these distances away from these people. And similarly, this person must have this distance away from everyone. And with all these relative distances, you get this. It's a neat way to do things, doing like a relative coordinate system.
So this is maybe done with like a spring model.
Yeah. I think it was exactly that. It was like a spring model. So everyone's the max distance they can be away, like attached to everyone. Yeah. So yeah, this is a good example of using some web scraping and then getting your data and actually doing a project with it. So hopefully all of you can go and web scrape and be it whatever you want, especially with language models now. That's all like web scrape data from the internet. I think ChatGPT was all publicly available data from the internet, so they had to scrape literally everything, which I can't imagine how long that took, but it ended up being 45 terabytes of just text. And that's,
I think for them, since they were gathering all of it with text,
yeah.
it was a lot easier because they didn't care about where it was located.
Oh, you just like get everything, just grab it, just grab everything. Yeah, because even scraping Wikipedia, like all of Wikipedia would probably be hard rather than just like straight up like downloading it.
Yeah.
Like
For common websites like Wikipedia and whatnot, you actually end up having backend APIs which are well maintained. So don't worry about using for them. You have REST API access. You can use stuff like just Postman and whatnot to get your data.
actually, I have another web scraper that I made. I don't have it loaded, but I have it on my GitHub. Where this was for a research project someone put me on. They wanted to scrape all publicly available data and threat reports for like certain classes of malware. So then we can aggregate that data into like a database that could be queried. So like if you want to know about like Android malware, it would give you like, here's everything from like Wikipedia, the MITRE database, like tweets and whatnot. And this type of web scraping, it started with Google, and basically we gave it like a seed URL. So like we got a driver that's basically Googling stuff for us, but we started with like different malware. These are different malware names. So like there's like Kung Fu malware, Ghost Push virus, like all these, creepy malware names. So at first it does a Google search, just like literally a Google search of all these, and then it goes in and clicks on all of the links that Google gives you, and then it'll go into those websites and click on all those links and start like collecting links and body of text. Yeah, this one is like a propagating web crawler where you start at a seed link and then you get all the links off of that, and then you check out all those links and then get all the links out of that. So like every generation, you're exponentially looking at more and more data. And I think I looked at only like, I did that like 10 times, like 10 generations. I ended up with like several thousand web pages. So it's a kind of a good catch-all. Yeah. So yeah, just another idea for you guys to use. So I will stop sharing. Kind of an impromptu, demonstration, but that's like real use cases I've used for class and for research. So I hope it was, educational. And yeah, do we have any questions on web scraping? Okay, with that, then we'll end the meeting. Thanks everyone for coming.